delta x by delta t, we have got this one. This is average change in, say, distance with respect to time. Now, if this change in time, that is delta t, be very small, x equal to 2 and x equal to 5 is f5 minus f2 by delta x, that is 21 by 3, 7. We can skip the steps like this. I have not written ddx of whole, I have applied this one. Already I have started discussing the meaning of derivative or dy dx in the earlier class, and I have discussed the general meaning of dy dx, also the meaning of dy dx in case of y equal to fx, a curve. Dy dx general meaning is that rate of change of y with respect to x, and geometrical meaning of dy dx is that it is the slope or gradient of the tangent to the curve y equal to fx. If we take the angle made by the tangent to the curve y equal to fx at xy be psi, then as per the meaning of dy dx, geometrical meaning rather, dy dx is equal to tan psi. Next, I am going to discuss the other meaning of dy dx, that is known as physical meaning. I shall first take the common matter. Let a particle start from a fixed point. We name the fixed point as O. A particle moves along the straight line OX from the fixed point O. Generally we call it origin. Let at time t it traverses the distance x. Then after a small period delta t, it further covers the distance delta x. Then we can say the distance x is a function of t, as the distance covered by the particle depends on time t. Therefore we can say x equal to at t. Therefore, as per that description x plus delta x is f of t plus delta t. Therefore, delta x is equal to f of t plus delta t minus x, that is equal to f of t plus delta t, delta t minus ft, as x equal to ft. Therefore, delta x by delta t is equal to f of t plus delta t minus ft by delta t. Delta x by delta t, we have got this one. This is average change in, say, distance with respect to time. Now, if this change in time, that is delta t, be very small, when delta t tends to 0, then delta x, delta t is the instantaneous rate of change of displacement that is velocity. We denote velocity by v, therefore v is equal to limit delta t tends to 0 delta x by delta t. Initially, we take the movement of the particle in straight path, but when delta t is very small, then that path may be curved also. This is nothing but, as per the symbol of derivative, v is equal to dx dt. Now, similarly, if we take the rate of change of velocity, then we get acceleration. Limit delta t tends to 0 delta v by delta t. That means after time t, velocity of the particle v, and after the gap of delta t time, its velocity becomes v plus delta v. Then if we calculate in this way, we will get acceleration is equal to limit delta t tends to 0 delta v by delta t, which is dv dt. Also, acceleration is equal to limit delta t tends to 0, or we can take this dvdt like this, ddt. In place of v, we put dx dt. Therefore, it becomes d2x dt2. These are very useful for the students who are reading physics. Therefore, acceleration is equal to d2x dt2, also dv dt. Again, we can write dv dt dv dx into dx dt. I have used here chain rule. Now dx dt is again v, therefore it is v dv dx. Thus we have got three expressions for acceleration. Here, keep in mind that time gap delta t is very small. Therefore, three expressions for acceleration are dv dt, d2x dt2 and v dv dx. We use any of these three forms as we require. Now, I have discussed here physical meaning. This is first case actually for velocity and acceleration. There are different meanings. Now I discuss other meanings briefly. Actually, we are discussing the first part of differentiation or derivatives or differential coefficient. The other part, which includes second order derivative or higher order derivatives, as well as interpretations, different interpretations of derivative in the second part. Next case is case B, when perimeter area of triangle as well as quadrilateral, also circle, depends on length, or in case of circle, radius. If each side of a square, generally we consider the cases of regular polygons. When we consider square, let each side be x, then therefore perimeter unit area Side may be dependent on t, or perimeter area may be dependent, you see, are dependent on x. Then we can consider, in case of perimeter, dp dx, that is rate of change of perimeter. Also dA dx, rate of change of area with respect to x, that means with respect to its side. Also this may be dependent on time. In those cases we consider dp dt, dA dt. Therefore, in case of plane figures, dp dx or dp dt and dA dx or dA dt, these are considered. That means rate of change of perimeter with respect to its side, rate of change of perimeter with respect to time, rate of change of area with respect to x, rate of change of area with respect to t, time. In case of triangle, generally we consider equilateral triangle, rate of change of perimeter, rate of change of area may be considered. In case of circle, if the radius be r, then we consider circumference as well as area. Then we can consider rate of change of its circumference with respect to time or with respect to r, rate of change of area with respect to r or with respect to time. That means dc dr or dc dt, dA dr or dA dt as per the given conditions. Next, we also consider the cases of surface area and volume of solid objects. In case of, say, cube, each edge say x, then surface area TSA, rather total surface area, will be 6 x square, volume x cube, of course cubic units. Then we consider, if I call it a dA dx, that means rate of change of surface area with respect to its edge, or dA dt with respect to time. Volume is denoted by the symbol V. Then dV dx, rate of change of volume with respect to its edge, or dV dt with respect to time t. Also, in many cases we use derivative of given function. Now this will be very much clear if we consider few examples. This one first. We have to find the average rate of change of y equal to x square in x equal to 2 and x equal to 5, and the rate of change of y at x equal to 2. Here delta x equal to 5 minus 2, that is 3, and f2 taking fx is equal to x square, f2 equal to 2 square 4, f5 that is equal to 5 square 25. Therefore f5 minus f2, 25 minus 4, 21. Therefore average rate of change in x equal to 2 and x equal to 5 is f5 minus f2 by delta x, that is 21 by 3, 7. No unit is mentioned here, therefore this is the average rate of change. Now we have to find the rate of change of y at x equal to 2. For that, second part, y is equal to x square, therefore dy dx, that is equal to d dx x square, that is equal to 2x. Rate of change of y at x equal to 2. That means this is the rate of change of y at certain value. Therefore rate of change of y at x equal to 2 is dy dx. We denote like this, x equal to 2. Now we put the value of x in this expression, that is 2 into 2, that is equal to 4. Therefore rate of change of y at x equal to 2 is this. We express that by writing dy dx at x equal to 2. It is read like this, dy dx at x equal to 2, that is equal to 4. That is the answer. Therefore for the first part this is the answer, and for second part this is the answer. Now I consider this one. You see, a ball covers a speed in t seconds given by this expression, s equal to 80 minus 10t square. We have to find the velocity of the ball at t equal to 2 seconds. Given s is equal to 8t minus 10t square. Now the velocity already I have deduced. In case of xt, x is the distance covered by the particle, t is the time, then velocity is dx dt. Here s is the distance covered by the ball, therefore ds dt is equal to ddt 8t minus 10t square. Ddt 8t minus ddt 10t square. We have applied the fundamental theorems of derivative. 8 is constant, ddt of t minus 10 is constant taken outside, ddt t square. Ddt of t is 1, therefore this is 8 minus 10 into 2t. Finally, eight minus 20t. That is the velocity. Therefore, velocity at t equal to 2 seconds is equal to, we put t equal to 2 seconds here, 8 minus 20 into 2. Minus 32. Here the unit of distance is feet and time is s. Therefore, finally we have to put velocity will be minus 32 feet per second. S is in terms of t, therefore ds dt, that is the velocity. We have calculated first ds dt at any time t, then I have put the value of the time t, that is equal to 2s, and calculated the velocity is minus 32 feet per second. Find the coordinates, find the slope of the tangent to the curve y is equal to 2 root x at 1, 2. We have to find the slope of the tangent for this given curve. Y is equal to 2 root x, therefore dy dx is equal to ddx 2 root x. 2 is the constant, therefore it is taken outside, then ddx x to the power half, that will be 2 into form x to the power n, therefore half x to the power half minus 1, that means 1 by root x. Now dy dx, the geometrical meaning of dy dx is the slope or gradient of the tangent to this curve y equal to 2 root x at any point xy. Therefore, we have to find the slope of the tangent. Therefore, the slope of the tangent at 1, 2 is equal to dy dx at the point 1, 2. Now dy dx is this one, 1 by root x at the point 1, 2 means here x equal to 1, y equal to 2. This is x, not 2. Therefore, it should be 1. Therefore, slope of the tangent to the curve y equal to 2 root x at the point 1, 2 is this one. It is required to find the angle of the tangent with the x-axis to this curve at this point. Therefore, already I have mentioned, if psi be the angle made by the tangent to the curve at the given point, then tan psi is dy dx at the point 1, 2, that is equal to 1, means tan 45 degree. Therefore, psi is equal to 45 degree. That is the angle made by the tangent to the curve y equal to 2 root x at the point 1, 2. Next sum, we have to find the coordinates of the point or points on the curve, this one, y equal to x plus 1 by x, where the tangents will be parallel to x-axis. Tangent, we don't know whether more tangent, therefore I write tangent within brackets will be parallel to x-axis. Therefore, psi is equal to 0. From that, tan psi is equal to 0. Slope will be 0. Therefore, dy dx equal to 0. Now, y is equal to x plus 1 by x. Therefore, dy dx is equal to ddx x plus ddx 1 by x. We can skip the steps like this. I have not written ddx of whole. I have applied this one. Next step, that is 1 minus 1 by x square. Now, dy dx is equal to 0, which implies 1 minus 1 by x square equal to 0. From that, x square equal to 1. Therefore, x is equal to plus minus 1. Therefore, at 2 points, the tangents to this curve will be parallel to the x-axis. For one, x will be 1, and for the other, x will be minus 1. Now, I drop this part to finish the sum. For x equal to 1, y is equal to 1 plus 1 by 1, that is 2. For x equal to minus 1, y is equal to minus 1 plus 1 by minus 1, that is minus 2. Therefore, the points on the curve y is equal to x plus 1 by x where the tangents will be parallel to x-axis are 1, 2 and -1, -2. Thus the sum is solved.